Hi guys, good morning. I hope you are all doing well. So just to let you guys know, I am coming down with another cold yet again. 'Tis the season. So I'm going to be probably a little hoarse. I apologize ahead of time. But today we're going to dive into the rest of the bases and what I consider to be a pattern modifier. But again, this may be not the correct terminology as far as where they are located mutation-wise on the locus. It's just how I'm going to present it, but we can always go back and fix terminology later on. Hi, Klaus. Good morning. Okay, this might be a rough one. Sorry, guys. So today we're going to talk about calico, we're going to talk about pansy, and then we're going to go into sparkly. So remember in episode 1 how I mentioned that there's gray area within color genetics? And this is going to be a video that really highlights that gray area. Okay, so I'm going to give you the most information that I have that's current, and I'm going to also let you guys know the bits of that information where there is gaps and where things may change as far as our understanding and our use of these mutations, how we incorporate them in our breeding projects, what we can expect from them, what they're compatible with versus what they're not, etc. So hello, good morning. I'm going to try to get through most of this content first, and then I'll go back and I'll answer any questions. If you do have questions, please put a Q in front of them so I can easily see them when I scroll back through. But let's start with calico. So I'm not going to get into the history or anything like that about the mutation. People can add that in the comments because it's really interesting information. But I'm going to keep it really simple. We're going to go back to our visuals, and I'm going to explain calico in heterozygous form and also in homozygous form the best that I can based on what we know right now. So calico, the locus that calico sits on is unknown currently. So we're in the process, because calico is a fairly new mutation that people are working with just recently within the US, also in Australia, in Europe. It's been popping up. And right now we have the opportunity to do a lot of different crosses and figure out exactly where that gene is located. And that will give us more information as far as, is it a technical base? Because we don't know if it's on MC1R. We just need more testing and more information. But for now, calico was originally believed to be a recessive gene, but it was changed, and now we have identified it as an autosomal incomplete dominant gene. The reason why it was originally thought to be recessive is because the phenotype, the appearance that it gives on a bird when there's just one copy of calico present, it's a very subtle phenotype, meaning it changes the appearance of the patterning of the bird, but in a very subtle way. So calico, we're going to talk about it being on a pharaoh base first. So when you cross calico and you end up with a heterozygous calico on a pharaoh or wild type base, it's going to look extremely similar to a pharaoh bird. So the areas that it does change and alter would be the wings, the back barring, like that center of that wild type feather seems to get more wide when it's heterozygous calico. And also there's more detailing in the wings, in the tail feathers, and usually you'll see this kind of warmth come through on the sides of where those tail feathers are. And it's going to look a little bit more red or orange in those areas. Then also when it comes to the face mask, I've noticed calico give more of a white coloring on that face mask area opposed to what Cadia, I mispronounced her name on the last video. Sorry, Katia. But what she has referred to as being that salmon pink color on a clean Pharaoh, this is more of like a crisp cream, almost white color on that face of the males. So calico, when it's heterozygous, the hens I have seen retain that chest spotting. I have spoken to other breeders, and it's seems to be that it's less chest spotting than a Pharaoh, and those spots on the hens will decrease over time. That seems to be what we think is going to be is happening with that phenotype. But you should be able to still feather sex them between 3 and 4 weeks if it's heterozygous calico on Pharaoh. Now, there may be exceptions with that because it's also said by other breeders as well that the phenotype can vary, the calico. It's not something that may be very, very specific that we're looking for and that we're seeing in every type of bird. It can vary. So you may get hens that are heterozygous for calico that have little to no spotting. So if you're unsure, I would definitely vent sex them come that 6 to 8 week mark, just to make sure that you're not accidentally putting heterozygous calico hens or homozygous calico hens in with your bachelor cage, bachelor mates. So in homozygous form on Pharaoh, calico will look very different than a Pharaoh in that case. The hens will have no chest speckles. The males will have no chest speckles, so they'll both have clear chests. And what it does is it predominantly, you'll see the markings of the calico, the pattern on the back, down the back side of the bird, in between the wings and on the tail feathers. The males will have more predominant head markings, so they are still feather sexable in that way, but it's not as obvious as, say, feather sexing a Pharaoh or feather sexing Manchurian. So it's a very interesting phenotype. And the patterning that it gives is more of like a kind of a shattered shape appearance. It's very different than Italian, and it's very different than Pharaoh when it's homozygous calico. I will add reference photos to the comments area for both heterozygous and homozygous, so you guys can see that, and I'm sure other breeders will add theirs as well. So before we move on, calico, this is the gray area that we're currently trying to test breed for and navigate through. And that is, what other mutations is calico compatible with? So right now we know that calico is compatible with fawn in its heterozygous form. So if you have, we'll take our visuals out again. If you have a hen, here's our Pharaoh hen, and she is also homozygous for fawn. So she's Manchurian or Italian, doesn't matter. In this case, we'll say Manchurian. This is what genetically she will look like. If we cross her to a homozygous calico male, we know that, here's our homozygous calico male. I'm going to try to take my time with these and really show you guys so I'm not rushing through visuals. We'll say that this is our homozygous calico male. So these are our parents. We know through test breeding currently that we can have heterozygous calico male or heterozygous calico on a homozygous, I believe, homozygous fawn. I may be incorrect there. Possibly we only have it on Italian. Possibly. This is that gray area, guys. If I'm wrong and if someone's done a test breeding project, then correct me. Just to be safe, we'll say that this is an Italian mom, okay? And that Italian mom can also hold a calico gene. So she can be heterozygous for fawn, heterozygous for calico. We know that for sure. I may be wrong with the homozygous fawn. I'll wait to see if someone corrects me there. But we know that we can have fawn and calico on the same bird. Whether or not we can have 2 copies of each is still unknown. So we're gonna put a pin in that, okay? But we can have fawn and calico on the same bird. Now, the same goes with EB. We can have heterozygous EB and heterozygous calico on the same bird as well. I have a feeling, this is not scientifically correct, that calico may be on the MC1R locus now that I'm thinking about it. If it is on the MC1R locus, we can only have Italian, so 1 copy of fawn, and heterozygous calico, because there's only 2 spaces for genes to be on MC1R in a single bird. And we would only have Rosetta with heterozygous calico, if that's the case. If we do more testing, and we do confirm, or someone confirms, that we can have a Manchurian with heterozygous calico, and we can have a Tibetan with heterozygous calico, that would be interesting, because that would tell us that the calico gene does not sit on MC1R, and it does not sit on the fawn locus, ASIP. So it's somewhere else completely. We don't know that. I don't know that. If someone else has more information, please share, because we'll be clearer in that. Okay, so there's the confusion. Klaus, last video, or the first video, he said, I can't wait till you confuse people with calico. There you go. There's the confusion with calico. So let's move on. If you have questions about calico first, let me know. Oh, well, let's not move on. Confusion continues. Calico is also compatible with diluter genes, okay? So we do not know exactly which diluter genes it's compatible with yet, but we do know that it's compatible with Phi, and I don't know if it can be homozygous or heterozygous, but heterozygous Phi, we'll say to keep it safe. It's compatible with Rue. I have seen photos of that, reference photos. I am currently testing it with blue, so I don't know the answer to that yet. Possibly someone else does. And I don't know about silver, and I don't know about Andalusian, and I don't know about lavender. So we'll put pins in those also, okay? Okay, so let's move on to Pansy, yet another one that I'm going to confuse you with because we have gray area. Pansy is probably the trickiest mutation that I can go into to try to have a really straightforward conversation with someone with. So Pansy is that kind of, it's a gene that's throwing a whole lot of questions out there as far as when we're visually identifying birds. It's acting really kind of funky, and we don't know, just like calico, we really don't know exactly how it works yet and how it looks on the different mutations paired with like fawn, paired with whatever it's compatible with. So Pansy, you can call it Pansy, you can call it rock cough, you can call it redhead. The clean Pansy I refer to as rock cough, meaning the Pansy gene, German Pansy, on a Pharaoh base. That phenotype, the way that that looks is, it gives it more of a scalloped patterning, right, for the feathers. The feathers will look more scalloped or like a barring pattern. And what it will do on Pharaoh is it will give the males a really bold, like a brick red head cap, which is really interesting and cool. And throughout the body, it will have a variety of kind of like a white color, black, and a red. And And that is predictable. You can breed homozygous rot cough and have a whole flock of rot cough. It's a very pretty mutation, and it's one that we're just really dabbling into now with more intention. So again, lots to be discovered. So rot cough is a different, or pansy is a different type of gene as far as the mode of inheritance goes. Calico is autosomal incomplete dominant, meaning it does not hide. So if a parent or if a baby has one copy of calico, you're going to see it, even though it's a very subtle phenotype. It may be very difficult for you to pinpoint if you have that in your flock, but it is there, so we can see it. It does not hide. Whereas pansy, if we were to have a bird that had one copy of pansy, we think that pansy is autosomal recessive, or a recessive gene. We may shift and change that understanding later, like we did with calico, if it's not, but currently that's what we're referring to it as. So right now, if pansy is in fact the autosomal incomplete or autosomal recessive gene that we think it is, if a bird has one copy of pansy, this is what happens. Instead of being able to visually see it, and we'll say we crossed a pansy to pharaoh, if that pharaoh also has one copy of pansy, that gene is going to hide. And that bird, even though it has that one copy of pansy in there, is going to appear to be pharaoh. That's the difference between an autosomal incomplete dominant gene and an autosomal recessive gene. This one does not hide. Recessive genes hide. So they're still there genetically, and this bird can still pass that on when you cross it to other birds. But as far as its personal or its phenotype, when you look at it, you will not see that pansy there. So this is where it's really important when you have recessive genes and you know that they're in your flock. If you don't want those recessive genes everywhere and random pansies popping up later where you don't expect them, then you want to keep that gene, or those group of birds that you have a feeling may carry those genes, even may carry those genes, separate from birds that you know do not. That way you won't have to test breed every single bird later on if you're trying to remove pansy from a breeding project. That can just be very difficult, again, because it hides, right? So this dad, we'll say, is heterozygous for pansy. The only way that you're actually going to see him have the pansy phenotype is if he is homozygous for pansy and has two copies of the pansy gene. What will happen then is he'll have two copies, but you will see it phenotype-wise in its full expression. Okay? So he goes from being an invisible pansy, one copy carrier, to homozygous pansy, and you can see it very, very clearly. So pansy also, I believe, people who are testing pansy with fawn need to chime in for me too, but I believe that we can have pansy with fawn. I don't know whether or not it can be homozygous or heterozygous. I don't know. I believe that it's located on the MC1R E locus, pansy is. If it is in fact located there, someone fact check me if I'm wrong. If it is in fact located there, we should be able to have homozygous pansy and also homozygous fawn on the same bird, because they would be two genes separated on two different locus. We should be able to have that if it's on MC1R. Reference photos I do not have of Pansy with fawn. Hopefully someone else does. That would be really cool. And let's see, let's talk about the other bases. This is why we think Pansy is located on MC1R, because crosses have been done with Pansy and with Extended Brown. Extended Brown we know is on MC1R. Pansy, when it's crossed to Extended Brown, as far as I'm aware, we have not been able to have a bird be Tibetan and also be homozygous for Pansy. Again, I'm going to wait for fact checkers. If there's someone who knows more about that than I do, please chime in, please share photos. That's why we have a hunch, or we have a strong belief that it is located on MC1R. Now, if it is, the most we could have genetically if we crossed Pansy to Extended Brown would be this. Have your Pharaoh-base bird, and I'm not using the same colors every time I give you guys examples. I hope that doesn't mess anyone up. But we have our Pharaoh-base bird. We have our one copy of Extended Brown on there. And we have our one copy of Pansy on there. Okay, so genetically, if they're both on MC1R, this is the max that we could have of each gene, right? Of the Extended Brown and of the Pansy. Now, since the Pansy is recessive, it's not going to look like a rosetta with Pansy on it. It's going to look just like a plain rosetta. But it's going to be carrying that Pansy gene. It's still there genetically. It can still be passed on to offspring. Okay? So in order to create a homozygous Pansy, it's easiest, in my opinion, to work with the rock cough on the Pharaoh base. Okay, just have it clean right from the get-go. If a Pansy project is in your is on your goal list. So in order to create homozygous Pansy, you can do it a couple of different ways. You can start with a homozygous Pansy dad. And then you can cross him to a Pharaoh mom. What that will do, sorry, Pansy is recessive, Allie. Know that this is recessive, right? Heterozygous copy is recessive. You won't see it. But you can take your homozygous Pansy dad and cross it to a Pharaoh mom. And what you will get from that cross is your baby who has one copy of Pansy. And that copy of Pansy will be hiding. So in this cross, you will create this from your first cross. This is the first generation result. All of those babies will be Pharaoh, and they will be hiding that one copy of Pansy. So they will all look like Pharaoh babies, but they'll all be genetically Pansy carriers or rot cough carriers. What you can do here to create your homozygous Pansy is, if you only have dad to work with, what you want to do is you want to continue selecting your breeders that's going to carry more and more of the Pansy genes that you're trying to all bring out to the surface, right? So let's say you have your babies. You're going to, in this case, take all of those hens that you know are rot cough carriers or Pansy carrier hens, and you're going to cross them back to dad or back to a different homozygous Pansy rooster that's not related. If you have that, it might be a better option. but in this case, we're going to talk about only having a few breeders to work with, what you can do. So if you cross these daughters back to dad, what you're going to end up with is some of those babies from that following cross. They're all going to grab one copy of that pansy from dad, and then half of them approximately they need to choose between these two things. Half of them are going to just grab Pharaoh and not grab this pansy gene, just grab Pharaoh from their mom. And those particular birds will be still just carriers. That pansy's going to hide. They'll be just carriers. However, the additional portion of babies, they're going to grab one copy of pansy from dad because they have to, right? He's homozygous for it. So they will grab that. And then they'll end up grabbing that one pansy gene from their mother, okay? It's a 50-50 chance whether or not they grab this. Those are the birds that are going to come from that second cross that you're going to see being homozygous pansy. From there, I would take just those homozygous pansies and any of the other ones that you have that are homozygous pansies, then you want to breed those together. That's how you will get a whole flock of homozygous pansy, homozygous rockcoff, right? Pansy being on a Pharaoh base. So that is how you would work with any type of recessive gene. If you're trying to bring a recessive trait out and have that bird phenotype-wise be homozygous for that trait, those are the steps that you have to go into a breeding project knowing. Now, another example of that, let's say that you don't have a homozygous pansy bird, but you know that it's a carrier, okay? Let's just say you know that it's a carrier. So here's dad. We'll say that he is heterozygous for pansy. Now, we won't be able to visually tell who's carriers because that hides. But if he is a carrier, I would do the same thing that you did that I just went through. If he was homozygous, same thing. Breed him to your Pharaoh or breed him to other suspected carriers if you know you have suspected carriers. And eventually, when you breed back, it may take 2 generations, hopefully not, hopefully just 1 generation, it will take 2 generations to be homozygous, 1 generation to produce heterozygous carriers. But eventually you'll see homozygous pansies popping out. Ideally, you want to work, if you have a recessive, if you want to work with a recessive trait, ideally it would help to have a homozygous bird of that trait. Does that make sense? It's just a lot less guesswork because you know exactly who it is that you can cross those carriers back to, okay? So let's see. What else is pansy compatible with? We'll go into the diluters. Diluters so far, it is compatible with homozygous phi. So you could have a heterozygous phi or a homozygous phi pansy. I am working right now on blue pansies. I'm only on the first cross with that, so I know that I have produced blue pansy carriers, but springtime I'll be doing that second cross to see if I have a homozygous blue pansy. I believe there is a reference photo somewhere of one, which is why I feel pretty confident that I will have homozygous blue pansy. But I haven't created it yet, and I haven't seen that picture personally yet. So we're going to put a question mark there too, because we also don't know the location of blue. So that's why it's a question mark. It needs more testing. Roux is compatible with pansy. You can have roux and phi on pansy. So you could have roux phi pansy. Silver, I have seen photos of. And I believe those are the only ones that I've actually seen photos of. So we can put a question. I don't know if it's compatible with Andalusian, not certain if it's compatible with blue, not certain if it's compatible with the Australian sandy dilute or the Australian OZ dilute recessive, because so far Australian breeders have not gotten their hands on Pansy yet. Pansy is not there that we know of right now, so that test, those crosses have not been able to be done yet. I have just put my Australian OZ dilute recessive that I have here, one of those hens, in with my Pansy male. So again, next year, hopefully I'll be able to tell you guys more about how it works with that gene in particular, but we just don't know yet. So I think that's it. Questions about Pansy, please put them in there. I may or may not be able to answer them, okay, guys? Because this is, again, we just, too much gray area to really be certain. So before I leave, we'll talk about Sparkly also. And this is going to be, again, where I probably do not use the right terms. Okay, I'm trying to explain this in the most simple way possible for backyard breeders who just want that basic understanding and how my brain works. So Sparkly, location-wise, may be on MC1R. We think it is. So technically, I think Sparkly technically would be a base. But the more common way we talk about it in the quail groups, like the Quail Colors and Genetics group, I'm very used to talking about it as if it's a pattern modifier. Whether or not it actually is, I don't know. But that's what I'm used to. So feel free to correct me on that. But Sparkly is a dominant gene, so it does not hide. And it makes quite a drastic change as far as the appearance of the bird is concerned, if it's in homozygous and if it's heterozygous. It throws some very interesting phenotypes. So heterozygous Sparkly, one copy of Sparkly. One copy of Sparkly. On Pharaoh, we'll say first, will create a bird that looks Pharaoh from the back, but what it will add to that bird is a very, like a sparkly pattern looking chest. So you're going to see a lot of patterning going on, and there's this unique thing that it does is it creates almost like a paintbrush type shape, like a vertical fan or a spike, but it's more of like a paintbrush type shape that is in the center of each one of those chest feathers, right? And they go, that patterning goes all the way down the belly of the Sparkly birds. So it's not just something that will be right up where typical chest speckles of a Pharaoh will be. It's going to extend all the way down that belly. And the chest is what you're going to be seeing having that different appearance when it's heterozygous Sparkly on Pharaoh. Now, when you have it on fawn, heterozygous Sparkly on fawn, it's the same type of shape that you'll see on the chest, but I find that it affects more. It affects more of the bird in heterozygous form on fawn. You'll be able to see it everywhere for the most part. I'll put reference photos there. To me, it just seems like phenotype-wise, it's just, there's more going on fawn than there is on Pharaoh. Maybe technically there isn't, but that's just how my eyes see it. So on both of those bases, they'll be feather sexable. And the male pharaohs, this is tricky for me to explain, so please stick with me while I try to find the best words, but on Pharaoh, you will see like a red, rust red background color behind all of that patterning on that chest area. On Heterozygous Sparkly Manchurians, 2 copies of fawn, you'll see that same red color in the background of that patterned chest area. Italians, however, 1 copy of fawn with 1 copy of sparkly, mine at least, do not have that same red rust in the background. They're still feather sexable. They still look male based on the face, their head caps, but I'm not seeing that really pronounced dark red in the background. I'm seeing it with Manchurians, not with my Italian males. That may just be my stock, but that's what I see here. If other people have reference photos of Italian males versus Manchurian males who are heterozygous sparkly and you have a chest picture, please put them in the comments, because I would be really interested personally to see if it's just my Italian boy sparklies here who are like that, or if there is a larger kind of variation phenotype wise that sparkly is throwing with fawn, which may be the case as well. So Sparkly and EB, you can have heterozygous sparkly and heterozygous EB. I don't think that you can have homozygous EB with heterozygous sparkly or homozygous sparkly. Someone who breeds sparklies needs to chime in here also and tell me if I'm wrong. But I do know that you can have Rosetta heterozygous sparklies, okay? So again, space for more information to come in the comment section, okay? Phenotype-wise, for homozygous sparkly, the phenotype looks very, 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 very different than a heterozygous sparkly bird. What will happen is that sparkly mutation will just overrun that bird, and the detailing will be all over the place. So you're not going to see just a difference in the chest. You're going to see a difference in the entire bird's plumage on the chest, the head, the back, everywhere. And what it looks like is more of like, it looks, if it's on Pharaoh and if it's on fawn, it looks more like it's a Rosetta-based EB, but it's not EB. Why it looks that way is because most of the plumage will take on that more uniform look, right? And what will happen is that you'll see a lot more, you'll see a lot of detailing within those feathers. I'll put reference pictures. And you'll see a difference between homozygous Pharaoh, homozygous Italian, and homozygous Manchurian. They're all homozygous for sparkly is what I mean. You'll see a difference between them, but it takes some time and it takes some practice to really be able to look at your homozygous sparkly birds if they're on Pharaoh, Italian, Manchurian, to be able to tell which is which, what exactly is their base pattern. It's tough to see in the beginning until you're used to looking at it and you can see the subtle differences. There's a reference photo, a side-by-side that Tamara put together of all those bases with homozygous sparkly, and that's the most amazing photo that I've seen with side-by-sides. Hopefully she can put that in the comments area for us. But there's a larger difference between homozygous sparkly Pharaoh and homozygous sparkly fawn color-wise. The Pharaoh looks more gray and the fawns look more brownish red. Okay, so you'll be able to see that in the pictures that we'll share. But sparkly is compatible with almost everything other than what we talked about with EB. And I don't know yet how it's compatible with calico, and I don't know yet how it's compatible with pansy. But everything else that we're much more familiar with and we have more of in circulation, we obviously have more information and pictures regarding. So you could have sparkly with V, you can have sparkly with roux, you can have sparkly with blue, you could have sparkly with silver, I believe. I don't know if I've actually ever seen a reference photo of sparkly silvers. I think I have, but that would be interesting to look into to see if we can find more reference photos of those. I personally have sparkly fawn Andalusians, which are really pretty. So it is compatible with Andalusian. And the OZ Sandy and OZ Dilute Recessive is also compatible with sparkly. Homozygous, heterozygous, doesn't matter. I may be leaving something out. Lavender, I'm not sure. I haven't seen reference photos of. So this, again, is just along the same lines as Calico and Pansy. Sparkly is fairly new to us here as far as using it intentionally and understanding what it is. So we have a whole lot more. We can probably do several other videos a year from now, 2 years from now, on all of those mutations, and we'd have a lot more information to actually be able to talk about and be confident with. Now, sparkly, just to go over the mode of inheritance with you guys too, while we're here, why not? So sparkly is autosomal incomplete dominant, so it will not hide, and you will see sparkly. I did have a question about whether or not I could go over how to remove certain genes from your flock. So if you don't want them in your flock, how do you go about removing them? I can go over that with sparkly just to give you an example. And that would be the same example that you would apply to your breeding program if you were working with any other autosomal incomplete dominant gene. Okay, so let's say that we have a sparkly pharaoh, heterozygous sparkly pharaoh mom, and a pharaoh dad. You guys are going to be really good at this because you're going to see me do it a million times, but this is what those birds would look like gene-wise, okay? So those babies, half those babies would just grab pharaoh, or all those babies would just grab pharaoh because that's all that dad has. So they'd all be pharaoh. I dropped my pharaoh. Hold on. Just a minute. So all those babies would have pharaoh. Half of those babies would grab just pharaoh from mom, and then half of them would grab one copy of sparkly from mom. So you would not have a case where all those babies would look the same. They would be 50% pharaoh, 50% heterozygous sparkly. If you had a homozygous sparkly mom on pharaoh base and just a regular pharaoh dad, all of those babies, 100%, would be heterozygous for sparkly on a pharaoh base. Okay? I am going to, on purpose, purposefully, repeat myself a million times when it comes to these words and how the different crosses work, because the more you hear it and the more you visualize it, it's going to click, okay? So it might be annoying for a little while, but I'm hoping that you guys will just write everything down in your notebook, and it's going to make sense, and all of it's going to come together the more we talk about it. So I think, let's talk about how to remove. If you have questions, feel free to add them now, because I'm going to do questions next. But let's talk about how to remove a gene, and we'll use sparkly as an example, from your flock if you don't want it, okay? So we've talked about how to increase your numbers, but if you do not want sparkly, let's say these are your breeders. You have a hen that is heterozygous for sparkly, and you have a dad who's pharaoh. She's pharaoh base too, but you only want pharaohs. You don't want sparkly in your pharaoh line. What do you do? And you have to work with her because you don't have many hens. Let's say that that's your current situation. So what you can do is breed them together still, okay? If you want her as a breeder and he's your rooster, breed them together still. The half of those babies that hatch out that do not end up getting that one copy of Sparkly, those are the ones that you're going to keep for your breeders in the next generation. You're just not going to use the ones that hatch out as homozygous or as heterozygous Sparkly, because if you continue breeding Sparkly to Sparkly, or Sparkly or homozygous Sparkly to non-Sparklies, you're going to just keep getting more Sparklies. So if you don't want to do that, you just omit the ones from that cross that are homozygous for the gene that you don't want to continue on with. Okay, whether it's you add that to a different breeding project, you sell it as a point of lay hen, you put it in your freezer, doesn't matter, but you're just not going to use it continuing on to your next breeding project. Now, Sparkly is one of those genes. I'll just give you a little bit more breeding tip, okay? Sparkly is one of those genes that I really, really love to keep in heterozygous form when I use it. I try to avoid keeping too many of my birds homozygous for Sparkly, because it's harder to see the underlying base pattern of that bird when it's got two copies of Sparkly on top. When I have a heterozygous Sparkly bird, you'll still see, all right, is the chin strap nice and clean? You'll still see if it's got sex-linked brown, you're going to really be able to visually see it. If it's a homozygous sex-linked brown rooster with heterozygous Sparkly, you'll see it. It's just easier for me to have more control over selecting my breeders when I'm selecting them from being a heterozygous Sparkly for the gene, not homozygous. In homozygous, everything's just kind of going to be, the detailing's going to be everywhere. You're not really going to see what's underneath. So I feel like I have less control when I'm trying to select breeders for the next breeding project. Also, homozygous Sparkly, some people may be able to feather sex them. I cannot feather sex them. So I consider them not being a feather sexable mutation. So if you want all feather sexable varieties within your flock, just to keep it simple, that is when I would use Sparkly, because it's beautiful, but keep your breeding program designed in a way that will keep the Sparkly gene heterozygous. So the way that you can easily do that is just select your hens. Let's say select all of your hens if you've got a lot of Sparkly, heterozygous Sparkly hens to a non-Sparkly rooster. That will give you half heterozygous Sparklies, half plain. And that's pretty much what I do here. There are other ways that you can do it, but that's to keep it simple. That's how I do it here. And you could just keep one Sparkly rooster and always just put him to non-Sparkly hens. So if he's heterozygous or homozygous, you can put him to non-Sparkly hens, and that can be your routine, right? Just use a Sparkly rooster, plain hens. Heterozygous Sparkly rooster would be best because, again, you can see the quality better on heterozygous. So you're looking for clean markings, right? Clean chin straps, clean back markings, all of that you're going to be able to visually see if you're using the heterozygous on Pharaoh. Heterozygous on Fawn is a little busier, but you get what I mean. All right, so this was a long video and lots of gray area, but I don't think I see any questions, guys. No questions. Okay, I'll return to the comment section later. I hope you guys have a great day. Hope I didn't confuse you too much, but the areas of confusion, please take note, because those are the ones that we're going to be paying attention to as far as new breeding programs or new test breeding. So there's some exciting things going on. Within the confusion, there's excitement. So I'll talk to you guys really soon. I hope you have a great day. Bye.